Okay, today we're going to start our Unit 5, and it is our first goal, and it's operations on functions, but this is just part 1. Tomorrow we will look at part 2, which is more operations with functions, but looking at the inverses. So we're going to look at basic operations, and then we're going to look at composition. So we'll look at the basic operations: add, subtract, multiply, divide, sum, difference, product, quotient, and then the composition of functions. So this we've kind of done, and we've actually done this too. It just looks a little bit different. So we're going to define that. So we can add, subtract, multiply, and divide functions. When we add, we just add each individual function to the other and combine like terms. When we subtract, same thing, but we subtract one function from the other, and we subtract all terms from the first function. Multiply, remember to multiply every term by each term of both functions. And then divide. On divide, we do need to write in the restriction. We cannot have 0 in the denominator. So that term, this expression, cannot equal 0. So because of that, we need to always write where x would be 0 and define that so that we never get a 0 in the bottom. So first we'll look at adding. So when I add these functions, I'm going to add the f function plus the g function. So f plus g, that's what it's asking me to do here, and write a new function, which would be the f plus g function. So I'm going to take 3x squared plus 7x, the f function, and then I'm going to add the g function, 2x squared minus x minus 1. So that is the g function. So I add like terms, so 3x squared plus 2x squared, 5x squared, 7x, and negative x, 6x, and my negative 1, and that's my f plus g of x function. So we've done this. This function notation is something that we have to do, or we need to know. F minus g, same thing, but you're going to take the f function and subtract the g function. So again, we start with our f function, and we're going to subtract the g function. We're going to put that in parentheses because we want to remember that subtracting is subtracting every term. So I'm going to subtract the 2x squared, subtract the negative x, subtract the negative 1. So I'm going to, in a sense, distribute this negative 1 here to everything. So I get 3x squared plus 7x minus 2x squared plus x plus 1. Then again, combine like terms. 3x squared minus 2x squared is x squared. 7x plus x is 8x plus 1. So this is f minus g. So we're kind of going through this fast because we've done this before, but make sure you ask questions if you're not sure. So notice this is closed circle, so when it's multiplying, this is going to be this closed circle. They kind of make a big deal of it because we are going to be looking at open circle, and that means something totally different. And we will be doing that here next. So this means the f function times the g function. So f times g of x would be 3x squared minus 2x plus 1, that whole function, times x minus 4. So again, f function, g function, and I'm multiplying it. So remember, when we multiply every term of this function to every term of this function, or you can go either way with multiplication. So I'm going to take every term by x, every term by negative 4. So 3x squared times x is 3x cubed. Negative 2x times x is negative 2x squared. X times 1 is x. Negative 4 times 3x squared, negative 12x squared. Negative 4 times negative 2x, positive 8x. Negative 4 times 1, negative 4. And then the same process as we did on the last equations, combine like terms, there's not another x cubed term. Negative 2x squared and negative 12x squared is negative 14x squared. X plus 8x is 9x. And excuse me, negative 4 doesn't have anyone to combine with. So that's my answer. This is a 9, x minus 4. All right, so division. This is where we need to make sure we write our restrictions. So we're taking an f function divided by the g function. So f function is 3x squared minus 2x plus 1, this function, and we're dividing it by x minus 4. So here we don't need to simplify that out, but we do remember we can't have 0 here, so we need to know where that x minus 4 equals 0. And you may just be able to see it. So x equals 4. So at 4, this would equal 0, and that would make this function undefined. So we want to make sure that they know x cannot equal 4, because we don't want the function to be undefined. So that is really the most that we're going to do with domain and range here. So I'm going to go to composition of functions. So composition of function is you taking a function and you're putting another function inside it. So if you notice here, we have the domain of g, so the x's of g, and then the range of g becomes the x's of the f, and that then gives me the range. So you've got these that you're putting it in, so you're putting the g function into the f function for f composed of g. So you're putting the g function in there, so it's going to go into the g function first. I'm going to have my output, and that's going to instantly drop into the f function. So here they're defining the functions as points. So f composed of g of x means that I start with the g function, 7. It goes in, comes out a 0, and that 0 goes into the f function, and notice when I put in a 0 in the f function, it gives me negative 1. Again, I'll start with the x of the g function, negative 1. That goes in, output is 7, so that becomes the input of my f function. When I put in a 7, I get a 7. Then I'll do 4. So 4 goes in, I get an output of 9. When I put a 9 in, I get an output of 4. So I put in a 4, ended with a 4. And then 8. So I put in 8, comes out a 2, and that 2 goes in, and it gives me a 6. So my domains of my f composed of g are all the domains of my g, and my range are these range of the f's, or the range of the f, or the y's of the f. So g composed of f is just opposite. It's going to go in the f function first and then end into the g function. So I put in a 2, I get a 6 out, but there's nowhere I can put in a 6 into the g function, so this is undefined. Put in a negative 1. Oops. Sorry, we're in the s. Put in a 9, I get a 4 out, plug in that 4 here, and look, I get a 9. Put in an 8, I get a 2, plug in a 2, I get a 6. And I forgot this guy, plug in a negative 1, out comes a 7, put in a 7, and out comes a 7. So those are my results of g composed of f. All right, let's look at it if I have a rule or an equation, an expression. I'm kind of going through that fast because let me get to here. So here I have not points, but I have an equation which would be infinitely many points and infinitely many points in here, infinitely many points from here. So I can't do each one. I can't find what I get for every point when I plug in every point of x and then put those points into the f. So I'm going to actually write an equation. So f composed of g of x is putting g into the f equation. So I'm putting the g function in for the f function. So I'm putting this function in to the x's of the f function. So 3 times 2x minus 1 squared minus 2x minus 1 plus 4. Remember, when you square this, you have to do 2x minus 1 times 2x minus 1. So you'll get 4x squared, 2x, or negative 1 times 2x, and negative 1 times 2x is negative 4x. Negative 1 times negative 1 is 1. Let's distribute that negative. And then distribute our 3. And then put like terms together. So then I get a new function that's f composed of g, with g inside of f. So g composed of f is just exactly opposite. I'm putting the f inside of the g function. So now I'm putting this inside of the g function. So I'd be 2. So here's my g function. And where that x is, I'm going to put the f function. 3x squared minus x plus 4 minus 1. Distribute my 2. And then put my like terms together. All right, so that's the lesson. If you have any questions, make sure you come on in.